Today, we are going to learn about LLMs. Millions log on every single day to write emails, debug code, and brainstorm ideas. When you type a prompt and watch the cursor type back, it creates a convincing simulation of a conscious, thinking entity. That entity is a large language model, a type of AI designed to read vast amounts of text, recognize the hidden patterns within it, and then generate language of its own. There is no mind behind the screen. Despite the sophisticated responses, this technology functions as a highly advanced autocomplete system. As we see in this split-screen comparison, traditional autocomplete might guess the next word in a vacuum, like suggesting morning after typing good. An LLM analyzes the broader context of your prompt to predict entire sentences, paragraphs, and complex ideas. The conversational partner you are chatting with is a mathematical prediction engine. The mystery lies in how a calculator of words achieves such a perfect illusion of comprehension. To build a prediction engine this capable, developers feed these models oceans of human data, including books, millions of websites, articles, and billions of lines of software code. By scanning this text during its training phase, the machine maps how humans write. It identifies the structural rules of grammar and traces how different ideas connect to one another. Computers cannot read full sentences the way people do. To process this information, the machine requires a different method of ingestion. It uses a process called tokenization. This system replaces human language with tokens, smaller mathematical units and fragments that the machine can compute. Look at this diagram of the sentence, ChatGPT is smart. The model processes this as a collection of fragmented geometric blocks. These pieces represent whole words, syllables, or single characters, and each carries a specific numerical value. By dismantling the human structure of a sentence and reducing it to mathematical tokens, the AI processes staggering amounts of text with brutal computational efficiency. Breaking language into millions of scattered numbers creates a challenge. Once these fragments exist, the machine determines which specific tokens are relevant to your prompt. This diagram illustrates the attention mechanism. The AI weighs the importance of different words, establishing which tokens share the strongest mathematical relationship. Adding a new context word instantly recalculates those weights, mapping relationships across a full thought to determine your intent. This mechanism lives within a deep learning architecture known as the transformer, introduced by Google researchers. Older models read text one word at a time, sequentially. The transformer architecture processes entire sentences simultaneously, allowing immense speed and a deeper grasp of context. This architecture sits beneath the hood of the most popular AI tools used today, driving systems like ChatGPT, Gemini, and Claude. This interaction between fragmented tokens and deep context produces the highly convincing simulation of human comprehension. Despite this complex mathematical architecture, LLMs do not possess consciousness. They lack the ability to actually think. They are blind to the concept of truth. When generating a response, the system calculates the most mathematically likely next word based on the historical patterns it absorbed during training. Because they prioritize statistical probability over factual accuracy, these models are prone to a failure known as hallucination. This probability tree shows exactly how a hallucination occurs. The AI delivers an incorrect answer with absolute confidence because a mathematical pattern suggested this specific sequence of tokens was the most likely outcome. Even with this limitation in grounding truth, these tools are altering how we work, how we learn, and how we create content. LLMs do not actually think, they simply predict, but they do it so well that it feels like intelligence.